Chapter 2, Atoms and Elements. And this is a quote from John Dalton. These observations have tacitly led to the conclusion, which seems universally adopted, that all bodies of sensible magnitude are constituted of a vast number of extremely small particles or atoms of matter. And this is something that, when you stop and think about it, is really kind of crazy. Because we look around and we see objects around us, right? Pencils and chairs and, computers and things. Each of those things, which is large enough to handle and see, is composed of extremely, extremely small, little tiny pieces. And it's those little tiny pieces that we're going to talk about in this chapter. So, another theoretical question. If you cut a piece of graphite from the tip of a pencil into smaller and smaller pieces, how far could you go? Could you divide it infinitely? Could you keep dividing it in half forever? Or would you come to a point where it could not be cut in half? Yeah, you're going to come to a point where you can't cut it in half. Because eventually you're going to end up with 2 carbon atoms. You cut that in half, and then you've got 1 carbon atom, and you can't cut a carbon atom. The word atom comes from the Greek word atomos, meaning indivisible. Now, of course, if we go into nuclear chemistry, the atom is not indivisible, but in chemical reactions, the atom is indivisible. What is true even in nuclear reactions, you can't take a carbon atom and make it into smaller pieces and still have it be carbon. It'd be something else. So atoms compose all ordinary matter. If we want to understand the stuff around us, then we need to understand atoms. Brownian motion. This was named for Robert Brown, 1827. He looked through a microscope at water-suspended particles that had come from pollen grains. And we're going to try to watch this.
I'm Dr. Jeff Binnicker, and today we're going to explore patterns of motion and friction.
I hate how they've monetized everything. So you see the particles, they're moving, right? This is the movement he was talking about. So, very short movie. So the question is, what was causing those little particles to move? At first I thought, well, maybe they're alive, right? They're not alive. So he thought they might be alive, but he finally decided that the source of the motion wasn't coming from the particles themselves. 1905, Albert Einstein, I think you've heard of him, developed a theory that explained this phenomenon called Brownian motion. And those particles are jiggling around because they're getting hit by water molecules. The water molecules are too small to see under that microscope, but we see the effect of them running into these larger particles, causing them to go one way and then another way, and they're just kind of jiggling around. A little bit like if you throw a beach ball out at a graduation ceremony or something where you've got a big crowd and people, hit the ball, right? And it just kind of goes all over the place. That's sort of the idea here. So Brownian motion infers the existence of atoms. Anybody have any questions about that? So another guy Jean Perrin did some experimental measurements that confirmed Einstein's theory, and that took away any doubt about the particulate nature of matter. That pretty much settled things. So fast forward a ways to the 1980s. A couple of guys at IBM in Switzerland were doing some work that led to the development of what's called STM, scanning tunneling microscopy. And this is a way of imaging things that's not visual. It doesn't rely on lenses and things. So there's a tip on this device here, and this is controlled by a computer and can be moved across in a pattern. At the very tip is a single atom, and they're going to pass a current through the air to the surface they're studying. That current is very sensitive to the distance it has to travel. So the computer adjusts the height of that tip to keep the current constant. And so as it goes across, if it encounters a bump like an atom, the current would decrease, and the computer says, oh, we need to move up just a teeny tiny bit, and it moves up. And so it can go across, and essentially it's feeling the top of the surface. Another movie. And I forgot about that. That one turned private on me, and I can't access it anymore. Sorry. What you get by scanning a surface is something that might look like this. Here what they've done is they've actually taken iron atoms and moved them around and spelled out in Japanese kanji characters atom.
So they did that mission?
Yeah. And the movie that I can't access shows how is the guy talking about how to do it. So let me try. So here we've got that tip. And so we can scan the surface, but if we get closer, if you get close enough to the surface, you can actually get an atom to stick to the tip. And then you can pick it up and move it over and set it down again. And so that's what they've done to create these characters here. They took some copper atoms and moved them around to form the kanji characters. That's pretty small. Let's see if this one works. Oh, good, it does. This is the world's smallest movie. So this is a technique called stop motion animation, where they take a picture and then they move some stuff and they take another picture and you put all those pictures together and it looks like the objects are moving. I don't think they're going to win any Grammys or anything for this. Scientists with maybe a little too much time on their hands. There's another video on YouTube that shows how that one's made. So if you're interested, you should definitely go check that one out. So just to give you an idea of how small those words were, or the letters, if you took all the books in the Library of Congress, and there's 35 million books, and they stretch 840 miles of shelving, if you wrote all the words using letters the size of the kanji characters, it would fit in an area of 5 square millimeters. 5 millimeters is just like that big, right? Kind of mind-boggling. Question?
What causes ripples?
That's a good question. What caused the ripples? That's sort of an artifact of the instrument, and I think it's related to other atoms that are sitting on the surface. Yeah, good question. So atoms are just mind-bogglingly small, right? But this is what connects the macroscopic world that we can see to the microscopic world and the particulate world. So an atom is the smallest identifiable unit of an element. I said before, they're like individual Lego building bricks. There are about 91 that occur naturally, different elements, and then there are over 20 synthetic elements, and every few years there's another one that somebody creates. Those are not found in nature, they're man-made, and then they're so unstable they fall apart immediately.